Hello everyone, welcome to my vlog. So for today's video, we'll tackle about the ellipse of conic section. An ellipse is the set of all points in a plane such that the sum of the distances from two points, foci, is a constant. When you go from point F or foc F to any point on the ellipse and then go to the point G, you will always travel the same distance. The two fixed points are called the foci of the ellipse. The midpoint of the line segment joining the foci is called the centre of the ellipse. The line segment through the foci of the ellipse is called the major axis and the line segment through the centre and perpendicular to the major axis is called the minor axis. The endpoints of the major axis are called the vertices of the ellipse. We denote that the length of the major axis by 2a, the length of the minor axis by 2b, and the distance between the foci by 2c. Thus, the length of the semi-major axis is a, and the semi-minor axis is b. Take a point P at one end of the major axis. Sum of the distance of the point P to the foci is Fp plus Gp is equal to Fo plus Op plus Gp, since Fp is equal to Fo plus Op is equal to cancel C plus A negative cancel C, which is A plus A is equal to 2A. Take a point at one end of the minor axis. Sum of the distance from the point Q to the foci is Fq plus GQ is equals to square root of B squared plus C squared plus square root of B squared plus C squared is equal to 2 square root of B squared plus C squared. Since both P and Q lies on the ellipse, by the definition of ellipse, we have 2 square root of B squared plus C squared is equals to 2A. Example A is equals to square root of B squared plus C squared. Or A squared is equals to B squared plus C squared is example C is equals to square root of A squared minus B squared. The eccentricity of an ellipse is the ratio of the distances from the centre of the ellipse to one of the foci and to one of the vertices of the ellipse, denoted by example A is equals to C all over A. Then, since the focus is at a distance of a C from the centre, in terms of the eccentricity, the focus is at a distance of AE from the centre. The equation of an ellipse is simplest if the centre of the ellipse is at the origin and the foci are on the x-axis or y-axis. We will derive the equation for the ellipse shown above in the figure with foci on the x-axis. Let F and G be the foci and O be the midpoint of the line segment FG. Let O be the origin and the line from O through G to the positive x-axis and the through F as the negative x-axis. Let the coordinates of F be negative C0 and G be positive C0. Let Pxy be any point on the ellipse such that the sum of the distance from P to the two foci be 2a, so given Pf plus Pj is equals to 2a. Using the distance formula, we have square root of x plus c squared plus y squared plus square root of quantity of x minus c squared plus y squared is equals to 2a, or square root of quantity of x plus c squared plus y squared is equals to 2a, negative square root of x minus c squared plus y. Squaring both sides, we get quantity of x plus c squared plus y squared is equals to 4a squared plus c squared plus y squared, negative 4a squared of x minus c squared plus c squared, which is y squared is be cancelled. Square binomials. X squared plus c squared plus 2xc is equals to 4a squared plus x squared plus c squared minus 2xc minus 4a squared of x minus c squared plus y squared, which is the x squared plus c squared will be cancelled. Or negative 4x c is equal to 4a squared minus 4a squared of x minus c squared plus y squared. Or square root of x minus c squared plus y squared is equal to a negative c all over ax.